Okay, time's up. Let's stop writing and work together. Ne? Let's stop writing and work together. Okay, sharp, sharp. Let's go. 7.1. 7.1. Let's read the statement to understand it. It says 6 years ago, Tabo bought a phone for 13,000. Okay, you stop and sort of interpret what they're saying. Today is the 15th of like July, or if you like, it's just the 1st of January 2025. 6 years ago, Utabo bought a phone for 13,000. So that means the value of the phone 6 years ago was 13,000, and obviously the current value is less than that of that specific phone, the old one that he owns. The value of the phone depreciated annually according to the reducing balance method. You guys remember that there's two primary types of depreciation. There's the straight line type of depreciation. There's also like the reducing balance. You guys remember reducing balance is on this formula: A equals P1 minus I to the power n, while the one on the straight line basis is P1 minus I dot n, like this. You guys remember that? Okay, so they go on to say the value of the phone is now 8,337.75. Calculate the annual depreciation. So we already know, first of all, that we are going to use the depreciation on reducing balance basis formula, which is this. Then we are given the current value of the phone. It is 8,337.75. We're also given the principal, the original value of the phone was 13,000. So it depreciated. So whenever you're dealing with depreciation, please note that this value here will always be less than that, ne? Because you're dealing with depreciation. This is the current value, this is the old value. Okay, so we go 1 minus our I. Our I is what we're looking for. So we're looking for the annual depreciation. So we're looking for that. And our N is how much? Can someone tell me what our N is? 6, ne? Because they specifically said 6 years ago this is what happened. So now what you're going to do is that you're going to now solve for I, ne? So the aim is for you to remain with I alone on one side. So you must get rid of everything surrounding I. The quickest thing to get rid of here is the 13,000. How do you do that? You must divide it by itself so that they can cancel. What you do on one side must be done on the other side. So on the left hand side, you'll have that value over there. You'll have 8,337.75 over 13,000. Do you get a normal number when you divide it? Do you get a normal number? Like a nice convenient number? I'll try it on my side as well. No, you don't get a nice number, so just leave it like that. So have 1 minus I to the power 6. So essentially we have 1 minus I to the power 6 equals 8,337.75 over 13,000. Okay, so now this is literally the same as having x to the power 6 equal to uh, 12. Okay, so remember, and they ask you to solve for x, you must get rid of this this exponent of 6. How do you do that? You take the 6th root. What you do on one side, you must also do on the other. Okay, 6th root of 12 plus minus 6th root of 12. This will give you x. Oh god, my pen's just stopped writing. Let's just fix it. Pen just stopped writing. Just give me a couple of seconds. So yeah, as we wait for the pen, I'll just explain. So we took the 6th root so that the root of 6 cancels the exponent of 6, and then on the left hand side, on right hand side we have plus minus root the 6th root of 12. Remember, whenever you're taking the root of an even number, you must have in front of the whatever you put in the root on, you must put plus minus. So if you have like 2, the square root or the 4th root or the 6th root or the 8th root, whenever this number here, why is this thing still frozen? Whenever this number, I hope you guys see. Okay, yeah, it's back. Yo, you guys, for how long couldn't you hear me? For how long couldn't you hear me? Here. Okay, so but do you guys understand what I mean by okay, okay, you didn't get that part. So I'm saying that whenever you come across like something like this, let's just say x to the power 6 is equal to something, maybe 5, or x to the power 7 equal to 5. You obviously take the sixth root here on both sides, ne? But you're gonna put a plus minus in front of that, ne? Why? Because whenever you're dealing with even numbers, when you're taking the root of even numbers, you must always put plus minus. But since this is odd, you don't have to put plus minus. It's just what it is. So you're gonna take seventh root of 5. It does not change. So numbers like 3, 5, 7, 9, 11, 13. Those are even odd numbers, so you don't have to put plus minus. But if it's a root of an even number, you must always put plus minus. Are we together? Yes? Yebo, yebo. You guys happy? Ne? Okay, I'm moving now. So on the left hand side, we will remain with 1 minus I equals this plus minus the sixth root. My God. Sixth root 8,337.75 over 13,000 like that. Okay. Then obviously you can take the one to the other side, or you can actually take the I to the other side so that it becomes a positive, and then take this one to the other side. It's going to have 1 minus. Let's leave this as a plus and see what happens. If this is a plus, we'll see. We'll test the minus and see what it gives us and reach a conclusion. Then this we take it to the other side. Can you guys punch for me quickly? Find me the I. I'm also going to do it on my side. What do you get? What do you get? What do you get? Okay, 7.13. That's beautiful. So when you calculate this, you get 0.07135, ne? And then obviously when you multiply it by 100, remember we're looking for the annual rate. It'll be 7.14%. That's proper. Be correct. So if you put a plus here, you're gonna get a 1 point something, which is not a percentage. You just leave it as a minus like that. So yeah. Do you all get the same answer? Yeah, boo. That's proper. That's super ultra proper. Okay. Sharp, sharp. So we happy with that? So let's do the second question. Is very interesting this one. I can't wait to do the last one. This guy, the guy said the paper is weird. Okay. It says Eric and Tandy need to save 80,000 rands each. So we must understand the opening statement. Each one of them must save 80,000 to go on a holiday at the end of December 2027. Okay. So that is on the 31st, essentially, on 31st of December 2027. Ne? So they haven't given us the current day, but we will just figure it out as we read the statement. Okay. So each one must save 80,000. Okay. Start with Tandy. Tandy decides that ne, she will start saving at the end of January 2025. You get a feeling that our current time is 1 January 2025. Okay. Tandy decides that she will start saving at the end of January 2025. She will make 36 monthly deposits, ne? 36 monthly deposits, that's essentially X, into a savings account that pays interest at 8.6% per annum compounded monthly. So it's 0.086 over what? Over 12. That's our I. Okay. Okay, so goes on to say the deposit will be made at the end of each month. Okay, so now when you look at Tandi's situation, it feels like it is literally the future value situation where someone makes regular payments at the end of regular time intervals. So in this case, at the end of every month, she makes some payment. They don't specify what payment it is, but some payment there. Okay, now you've got your X. Let's write it in a brighter color. X. You've got your I. And what else do you have? You've got the N. Remember that under the future value formula, N represents the number of payments. Okay, so future value formula X 1 plus I N minus 1, like that. Ne? So you've got the X, you've got the I, you've got the N. So that means you you don't have the X. Sorry, you don't have the X. This is N. Sorry, the 36 is N. Sorry about that. This is your N36. Then your X you don't have. Your I you already have. This. Okay, and then your future value is 80,000. Remember that Utandi wants to accrue her savings to 80,000 because each of them has to pay 80,000. So that means, and the deposit will be made at it. That means you are able to find the X there, and we know the formula for X is just X. We'll make it the subject of the formula. It is that. We've done that last week. Then we go X is equal to 80,000 is what she's saving towards Utandi, and then our I, we've already sort of established it there. Then we've got 1 plus 0.086 over 12 to the power, number of payments 36 minus 1. Can you guys punch this for me? I'll also do it on my side. Is Elizabeth still here? Because I remember she had issues with the network. Siyabonga madoda, in full force. Did you log out from your phone? Even when you have your mic muted, it still lags, overlaps. It should be the network, ne? Because normally for me it does that, it overlaps when I have the laptop connected and my phone as well. So yeah, maybe that's why. We'll pray for it, ne? Please pray for it so that it doesn't give you problems. So this one doesn't require anything; it just requires prayers, ne? But I'm glad you're still here. You understand? Okay, what answer did you guys get for me there? What answer did you get? Proper stuff, proper stuff. You're on fire. Someone needs to put you out. Okay, proper. Okay, so now, so what happened here? Do you guys need to open your minds when you read these statements? So these two people, Tandy and Eric, are probably going on. Yeah, they are going on a holiday, and then each one needs to save 80,000. So that means the holiday is probably 180,000. So Bartandi decides she will start saving at the end of January 2025. So this is something that's going to happen in the future, right? So Tandi decides to start saving. She makes a monthly deposit of 36 monthly deposit. So that's your N, and then here's your interest, and then your future value is 80. So that's our monthly payment Tandi is going to make. Now let's go to Eric. Eric calculates that if he makes 48, he calculates if he makes 48, if he makes 48 deposits of 1.4, 1.402.31, starting at the end of January 2024, he will have enough money to go on holiday. So according to Eric's calculations, if he makes monthly deposits of 1,402.31, starting at the end of January, 31 January 2024, he will have enough money to go on holiday. He'll make his deposit into a savings account at the end of each month. Ne? So now, do you see that here we've got an X, here we've got an N, then here we've got an I. So what we don't have is essentially how, okay, he will make his deposit into a savings account at the end of each month. The savings account pays interest. Okay, so essentially here, Eric's situation is slightly different to Tandy's situation. Eric puts in the same amount of money at the end of every one. Let me read again. Eric calculates that if he makes 48 deposits of this much starting at the end of January 2024, he will have enough money to go on holiday. He'll make his deposits into a account at the end of each month. Okay, sharp. The savings account pays interest at this much compounded monthly. So now the question says, oh yeah, okay. So now what you're gonna do in Eric's situation, I think you're gonna sort of see if this gives you like a future value of 80,000. So what am I saying? You're gonna do this. You're gonna use the future value formula and go. X is 1,402 like that, ne? That's the scenario, ne? And then 1 plus you put your I in. Our thingy, our N is 48, because they say he makes 48 deposits. Minus 1 over our I. I think that's what the situation is. I'll just check it shortly. Okay, let's read the question. So this question will give us more light. Calculate the difference between the total that Eric and Tandy will deposit into the respective savings over the period. So they're asking, like, calculate the difference between the total amounts. So total amounts are this. So total amount for Tandy will be this. This amount already calculated the X for Tandy. We're just gonna go 1955.78 times how many payments does Utandi make? She makes 36 payments. So we're just looking at the total payment she makes. So you guys multiply this thing by 36 and tell me the answer. Are we happy? Fairly. Now let's move to let's now calculate the total Eric paid. So he made payments of 1,402.31 48 times. So it's 1,000. Is it 1,3 or 3,1? 3,1 times 36 48, sorry. So can you guys tell me the answer there? Can you guys give me the answer? What is 1,402.31 times 48? Proper stuff. So now they asked you what is the calculate the difference between the total Eric paid and Tandy paid. So the difference will be 70,000 minus that. Okay, it'll be 70,000 minus 67,310.88, which gives us how much? $70,408, whatever. Can you do the whole calculation? I mispronounced it. Okay, so this is the difference. The reason why the examiner asked you to calculate the difference is that the examiner wants to show you Tandy's decision was wrong, because even though both of them will save to get 80,000 after whatever number of years, Utandi pays 3,000 rands more, 3,000 rands, 97 rands more. So you should rather take Eric's sort of path. Yabo? So the reason why you getting this question is to show you what Tandy made the wrong decision by taking that investment instead of taking Eric's investment. Does that make sense, Matot? Yes, no? Proper stuff. So I'm gonna close this thing. What's this thing? The recording, and then I'm gonna ask you guys to do the last question. So I'm gonna close this recording and save.